Hi, everybody, and welcome back to Chee-Tash. My name is Chris, and today we're going to be continuing along with Chapter 17 from the book Clean Code, going over the reference list of smells and heuristics to round out the ending of this book, or the final chapter of this book. Last time was part 2. We've had 2 parts to this chapter so far, just going over a pretty comprehensive list of common smells and heuristics. Today we're just going to continue along. If you guys remember, last time we talked about this, functions should descend to only one level of abstraction, which was basically saying, hey, a function should be broken up if it's going and doing other things, right? That's like the single responsibility principle that we've talked about in earlier videos. And he basically says here, a function should really only have just one level of abstraction. So it shouldn't go into other deeper levels within the function itself. And basically, this is saying, if you guys want to simplify this, it's basically saying, hey, it should really only do one thing. When you have multiple levels of abstraction, so if within one function you have another function which contains another function and another, and et cetera, then it's really hard for it to do just one thing. So break it up so that it only goes one level deep from there. And you can kind of tell that with indents, I find. When stuff is indented, it usually means like it's within something. This happens when you have if conditional. So when you have an if conditional, the lines inside of the if conditional get indented one line or 5 spaces or whatever a tab is within the if. It'd be better to show you guys an example, so hopefully you guys understand what I'm saying there. But we went over that one last time, and let's just continue along here with this next bullet point. Keep configurable data at high levels, such as constants. And Uncle Bob says you don't want to bury these into low-level functions. So if you do have stuff like constants that pretty much stay the same throughout your whole code, you want to put them at just the very, very top level of a class and not instantiate them or create them within low-level functions of that class. Next, avoid transitive navigation. So this is the law of Demeter that we talked about in a chapter in an earlier video of this book, which is another way of saying writing shy code. And I'm trying to figure out like what's shy about this, but basically transitive navigation, what Uncle Bob means here is that modules should only know about their immediate collaborators. So there shouldn't be a transitive property. And if you guys know the transitive property, I think it's from geometry. It's like if A equals B and then B equals C, then A equals C or something like that, right? But in software development, and I'm gonna write here, I'm gonna read here how he puts it. If A collaborates with B and B collaborates with C, we don't want modules that use A to know about C. So I guess shy in that, like, you don't want A crossing over into C and knowing about C. And this basically starts to make your project app more rigid and a little bit harder to construe and possibly harder to figure out what's going on in your project. So he says, you want to follow the law of Demeter and you want to avoid this transitive navigation. Next up, we're going to get into some Java-based smells and heuristics. So starting off, avoid long import lists by using wildcards. And I'm going to be honest with you guys, this is actually something on my current team that we avoid. We actually avoid this .star import. So if you have like Java, you're importing java.util, we actually list out everything .map, .list, .hashmap. And what Uncle Bob is saying is it's better to use the star wildcard. So you just say import java.util.star. You're going to import everything from the util package, right? So map, list, array list, all that stuff. But on my current project, we actually list everything out. And I think the reason why we do that is just for clarity, and because if we don't need something, we don't want to just import everything. But I get what Uncle Bob here is saying, is that this leaves your imports much cleaner when you just say .star. It could potentially take your imports list from like hundreds of imports to, just like a few, like 10, 20, right? Something like that. And it just greatly reduces the size of your file. But he does admit here that sometimes the long list of imports is good to find out what you specifically need to mock or stub. So this could be good in a situation where, okay, if I don't know what all is being imported from java.util, then it's going to make it hard for me to mock things in my tests. This way, I'm going to have to actually look deeper into the test file in order to figure out what exactly I'm using. So there's pros and cons to this. Next up, don't inherit constants like from an interface, because it makes it hard to track down. Instead, says Uncle Bob, you should be creating static classes and importing them. So you guys know that when you implement or when you create an interface, you can then implement it in other classes, right? You can put constants within an interface and then have other classes implement that interface and then use the constants, right? But Uncle Bob here is saying that this kind of makes it hard to track down. And instead, you should create, I know I've used instead like 3 times in a row just now, but you should create static classes and then import them. So instead of saying implements, payroll constants, which are going to contain constant variables in regards to payroll, you should instead create a static payroll constants class and then import static payroll constants to get all the payroll constants from the static class instead of the interface. Because Uncle Bob says you don't want to use inheritance as a way to cheat the scoping rules of the language. Because potentially, I guess, you can potentially here, the meaning of those constants can get buried in the implementation because it's within an interface somewhere and it makes it kind of hard to track down. So it's better to just use the import at the top of the class. That way you know it's exactly coming from there. Continuing along this, constants and enums. The meaning of enums cannot get lost. They bring more to the table, methods and fields. So sometimes, a lot of times, I think actually Uncle Bob says it's better to use enums. It's better to use enums than constants because the meaning of an enum cannot get lost. So an enum, an enumeration, I think that's what it stands for in Java, is like you name it, that is what it is, and there's no misconstruing it, basically. I guess with constants, they really do seem similar. They really do seem similar, except for the fact that enums you can use methods on the enums, you can use fields on the enums, and there might need to be a video just entirely on enums, but Uncle Bob is just really big into if you can use an enum over a constant, you should. Next up, names. We've talked a lot about this. Choose descriptive names because it's what makes software readable and legible and makes you better understand what your code is doing. Choose names at the appropriate level of abstraction. So don't pick names that indicate implementation. Pick names that indicate abstraction. So an example here that I got from ChatGPT was, if you name something simple interest calculator versus interest calculator, Simple interest calculator is depicting an implementation, and you should really name things at an abstraction level. So you name something an interest calculator so that then later you can name something a simple interest calculator, and you go just one level of abstraction higher for a better organization, and it makes things easier to understand and reuse. Next up, use standard nomenclature where possible. This is essentially getting your team to collectively come up with a game plan for how you want to name functions and classes and constants and enums within your code, and then use that throughout your whole entire project without taking into account how everybody else does their projects. And this is called a ubiquitous language, where you tailor specific naming standards specifically to your project. So just standardize it for your project. If you're going to name something in a certain way, prefix it with something, do it within your project, and make sure everybody else is on the same page. Unambiguous names. I actually got to go back. I think this is just, you want to name things. You want to choose names that make the workings of a function or a variable unambiguous. Oh, gotcha. Okay, so we've talked a lot about this. Is you should really name things in a way that makes you understand what that function or class does after reading the name versus having to dig deeper inside the code to understand what it's doing. So naming, if you have a payroll calculator, name a class payroll calculator. Don't name it calculator, right? Or maybe you can name it calculator, and then you abstract out from there to implement the calculator class or extend the calculator class to have a payroll calculator. Something like that. So you know exactly what that's doing. You don't want to just name it payroll, right? Because maybe it's not doing, what exactly is it doing with payroll? Is it calculating it, or are you getting employee payroll information? And it should just, maybe you can have a payroll class, but then you can have different methods within that class that do specific functions. So just, you guys see what I'm saying here. Don't use unambiguous names. Make sure the function or the main usage of whatever you're naming is clear within the name. Use long names for long scopes, and then use short names for short scopes. So think about this in the context of using for loops. When you write out an iterative for loop and you do the initializer, the limit, and then the incrementer, right? You know how you use int I equals 0 to depict, okay, we're starting at index 0. That's a good use of a name for that scope because it's such a small scope. You can name something int I instead of saying int starting index. I mean, you could do that, but is it really necessary? No. But now for longer scopes, you want to use longer names so that you're better able to understand and follow the code. So just think about for short scopes like for loops or counting variables, it's okay to use short variable names. But for names that are going to be used in a longer scope of a function, like throughout a whole function, you want something a little more descriptive. Avoid encodings. There's really no need for these encodings anymore. I think there maybe was in earlier programming languages, but no need for an M underscore or an F, before a function, F underscore, so you understand that it's a function, or no use for this viz underscore, which was for visual imaging system, what Uncle Bob says. So there's really no need for these encodings anymore, at least in Java. And maybe, I think in a lot of today's programming languages. Next up, names should describe the side effects. So we talked about side effects are like things that a function does that are outside of the scope of its normal responsibility. So names should describe everything that a function, variable, or a class is or does. Don't hide the side effects with a name. Don't use a simple verb to describe a function that does more than just that simple action. So just make sure, again, make sure the usage or the function or the action of that function or method, class, variable, whatever, is completely known by the name. So kind of like what we talked about with unambiguous names, names should just totally spell out what it is that thing's going to be doing. Next up, all about tests, and we need sufficient tests. So insufficient tests are not a good thing. Your test should adequately cover scenarios, they should adequately cover lines, and this is just to make your code just way more cleaner and making sure that it runs and the project builds and you know exactly what your code is doing, basically. How much is enough? Well, they make tools for this, such as Sonar. They make IntelliJ has a coverage tool where you can, or a run configuration rather, where you can run your test suite and it will actually print out the coverage report. And it'll actually show the coverage colors within your classes. It'll show on the left-hand side where the line numbers are, it'll show you if green if it's covered, red if it's not covered. So those are great coverage tools to test out if you have sufficient tests. Don't skip trivial tests. So tests that are easy, or sorry, don't skip writing tests at all, basically, is what this point means. You want to make sure that your code is doing what it is doing, and you just don't want to skip or not have any tests at all. An ignored test is a question about ambiguity. Sorry. Sometimes you're going to have ignored tests. Sometimes you're going to have tests that, I don't want to say commented out, but you're not going to have tests that are written for certain pieces of code where you see that it is not covered. Ignored tests, which are usually, like if we're talking about from a Java and like Spring Boot perspective, you can annotate tests with an ignored. And this basically means that a test is no longer needed. Maybe it probably could even just be removed, but it's not needed because some part of the code base changed and the test is no longer relevant. But maybe you're keeping it just for, documentation's sake. And maybe the code base changes back and you unignore the test so that it runs in your pipeline now. So an ignored test just usually means maybe a piece of the code is still in development or maybe it's no longer needed anymore. Testing the boundary conditions, a very good point. You shouldn't just test like best case scenarios for your code. You should test like the very outlier test conditions to make sure you catch all those different scenarios and make sure your code is working in all those different scenarios. Next, exhaustively test near bugs. If you find a bug, keep testing to make sure there are no more. And Uncle Bob, I think he lays it out here where he says bugs tend to congregate together. They're found in groups, right? So if you find one bug, then exhaustively test if there's other bugs near that condition or near that piece of code that you're finding that bug. And then last slide, guys, patterns of failure are revealing. So for example, if you have a test that with every large input, like a number over 1,000, that it's failing, well, that's maybe an indication that you need to relook at the test or relook at the code base to see, well, why with this large input is it failing? If you see those types of patterns, then that something is up. So just pay attention to those. And going along with that, test coverage patterns can be revealing. You basically get to see what code got executed and what didn't. So if you're testing out a function with multiple if conditions within it, and maybe you could argue that you could abstract that out, right? But anyways, if you did have conditional statements within it, and some of them get executed, but maybe the last one doesn't, well, that's an indication that, oh, okay, I need to go back and I need to either figure out why this isn't getting executed, or maybe something's up with my test, and maybe I just need a new test to cover that if conditional. Happens with me all the time. I actually have a scenario right now where I'm trying to get test coverage on a conditional. And then lastly, test should be fast. A slow test is a test that won't get run. So your tests should be pretty self-explanatory, and they should pretty much just run right away. I will say with this, I find that like on my current role, we have integration tests, which take a long time to run sometimes. So I think, yes, unit tests should probably be pretty quick and to the point. But integration tests, those tests that test out the long action, the long form action of like a controller endpoint, if we're talking about Spring Boot, like a save employee, right? We want to test the whole and functionality of save employee. Well, you got to test out your service class. You got to test out like the DB that it saves in there. You got to test out the response back to the user. So that's kind of what an integration test is. That might take some time, but a unit test, I agree. A unit test should run pretty quick. And that's going to do it, guys. That's the end of chapter 17, and technically, that's the end of the book. There's a couple appendix sections. There's one on concurrency, and then appendix B is on serial date. The one on concurrency actually might be something that might be worth exploring with you guys. So maybe I might do that. We might go back to like our grocery store example that we did a few videos ago. And I know I've gotten a few comments now to go back to the eloquent JavaScript video. So maybe we might just roll right into doing videos and going over that book while I decide on what is another good book to do. Seems like the software stuff is popular, and I think people like it. Although, I like doing books, like the 4 Agreements or the Subtle Art of Not Giving a Fuck. So we'll see. Maybe I'll do them both, but it'd be kind of hard too with the interviews that I got going on, which we've got a new one dropping today, same time that you'll see this video. So yeah, big things coming. Let me know what you guys think. Let me know if you have any questions, and thank you guys so much for listening and watching. We just hit over 1,000 subscribers too, so thank you very much. And we'll talk soon. Thanks again, everybody. My name is Chris. This is Chee-Tash. Take care.